All right, so here we have a summary video for 0.3 graphing. And we have two main forms we deal with, and that's standard and y-intercept, also known as y equals mx plus b. And over here we have ax plus by equals c. Right? And these are both really the same thing, just in different formats. So in standard form, we're going to usually have numbers replacing the a and the b and the c. So 2x plus 3y equals 6. For slope-intercept, we'll have something like y equals 2/3 x plus 1. Or it might not even have a fraction. It might be y equals negative 3x minus 4. Okay, something like that. Now, these are both graphed in different ways, and you can convert back and forth between the two. But it's much easier if you can learn how to graph based on what you have using the advantage of that system. Okay? Now, in standard form, as long as these two numbers are factors of this number, we can do what's called the cover-up method. Okay? So when we go to graph this, let's put it over here, 2x plus 3y equals 6. Okay? We talked earlier about x and y intercepts. Well, we're going to try to find those intercepts and put them on the graph. So if you think about it, the x-intercept is here or here or here, something like that. Okay? These points, this would be negative 8, 0. This would be 2, 0. This would be 3, 4, 5, 6, 7, 8, 9, 10, 0. Okay? If you notice, all of the x-intercepts have a 0 in the y. That's because it does not come above or below the y-axis. I mean the x-axis. You don't go up or down. You just move left and right. So for an x-intercept, we're going to plug in a 0 for y. And we're going to solve here for x. Okay, let's do that here. We're going to plug in a 0 right here for that y, which is basically going to make that disappear, hence the cover-up method. And you just have 2x equals 6. If you divide by 2, x is 3. So we're going to put a dot here at 3, 0. 1, 2, 3, 0. There is your x-intercept. Okay? Now, consequently, all of our y-intercepts will be the similar thing, except the 0 will be in the x spot. So we're going to plug the 0 in here and cover up the x and solve 3y equals x, divide both sides by 3, and we have 0, 2. And that is those are two of our points on our line, and we can draw using a straight edge through there and connect the dots and get a nice line. Now we can't really put a straight edge on this because it's a touchscreen, but there's a trick. I also know what the slope is here. I can go down 1, 2, right 1, 2, 3, which means I can go down 2, 1, 2, 3 to the right. I can go up 2 and 3 to the left and get more points to get a more accurate line when I'm drawing this, especially if I am freehanding like I am here, but we always want to use a straight edge. And there's my line. 2x plus 3y equals 6. Simple enough to do. Okay? Let's try a couple more of these. 2x plus 4y equals 8. Now, again, we look and see at 2 and 4 both going to 8, we're good to go. Okay, so I'm going to do the cover-up method. I'm going to plug in a 0 for x and find out what I get for y. Well, 4y equals 8, divide by 4, I have 2. Do the cover-up method this way, which means I'm going to plug in a 0 for my y. 2x equals 8, divide by 2, and I have 4. So my 2 points are 0, 2, and 4, 0. 1, 2, 3, 4. And again, I can real quickly find out my slope. It's down 2, right 1, 2, 3, 4, which means I can go down 2, 1, 2, 3, 4 to the right, or up 2, and 1, 2, 3, 4 to the left. And again, I would use a straight edge on paper, but there's my line. And again, what was my slope? Down 2, right 4, positive, which reduces to negative 1 over 2, which if you think about it, if I count down 1 right and over 2 to the right, down 1, right 2, up 1, left 2, if I was using a straight edge, you would see that I'm hitting all those points. A negative 1/2 slope. And as I said before, another hint is if I write my name on it, it's going downhill. That means it's negative. Let's try another one here. Let's try getting a negative in there. 4x minus 2y equals 16. Well, again, if I plug in a 0 for my x, which means I'm going to cover this up, I'm going to divide both sides by negative 2 and get negative 8. Whoops. Not able to grab the cover up for some reason this time. So let's just pretend, sorry about that. I'm going to put my 0 in for y. Let's pretend we can see the 4. 16 divided by 4 is 4. So this time, my y-intercept is at 0, negative 1, 2, 3, 4, 5, 6, 7, 8. And my x-intercept is at 1, 2, 3, 4, 0. Okay, well, if I count, now I can't go down much more, but let's figure out what my slope is. I go up 8, right 4, up 8, right 4. That's a slope of 2, which means I could go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, and there I am. And now I have a bunch of more points in between. Again, I could do that this way here. I could even go down 2 and left 1 there, and there I have my line. Again, straight edge will make this much better. And my slope is 2. And again, it's a positive slope, which means when my name is going on the line, it's going uphill. Let's do one more with coefficient of just 1. X plus 6y equals 12. Okay. Well, again, I'm going to put a 0 in here and a 0 in for y. When I put the 0 in for x, okay, that means I'm really covering that up, and I'm solving for my y, which is right here. 12 divided by 6 is 2. That's a point at 0, 2. Let's see if this will work this time. Oh, it did work. Good. So when I plug in a 0 for y, there's nothing to divide by. It's simply 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Which means if I go down 2, right 12, or that reduces to negative 1 over 6, which gives me another dot. 1, 2, 3, 4, 5, 6. Another dot for connecting. I can't go any more off to the right here, but I can go up 1, 2, 3, 4, 5, 6, and get myself another dot there. That just gives me a little bit more guidance when I'm drawing my line, but again, a straight edge will keep me from having an error there. And it's a slight slope, but my name is slightly going downhill, -1/6 slope. All right. Let's go back to slope-intercept form. With slope-intercept form, you simply identify the slope and the y-intercept. This is the y-intercept. Okay? So let's look at that first one, 2/3 x plus 1. Well, you find your y-intercept, which is at 0, 1, right here, and then we go according to the slope. 2/3 is positive, which means we're going to go up 2 and right 3. And we just keep doing that. As many times as we want. Oops, that was 2, 2. Didn't count over enough. Up 2, right 3. And that gives me plenty of points, but 2/3 is really the same as -2/-3 because that is still positive. So I could go down 2, left 3, down 2, left 3. And sometimes you need to do this when you're, if your y-intercept was at 9 or 12, it would be hard to go up and to the right, but you could go down and to the left to get more points. And again, positive slope. Let's try a few more. Let's do a negative slope of 3/4. And let's start with -5. Oh, I forgot my x. -3/4 x minus 5. All right, well, that means I go down 1, 2, 3, 4, 5. To 0, -5 is my y-intercept. Remember, x is 0. And then I'm going to move -3/4. Or 3/-4, same thing. What this means is down 3 and up, not up, that's silly, right 4. Or I could go up 3 and left 4. So let's see how that looks. Down 3, 1, 2, 3, right 4. 1, 2, 3, 4. Right now, if I connected those dots, my name would be going downhill. So that's good. It's always a good way to test that to make sure you don't put the dot over here. And your name would be going uphill. And we don't want that. It's a negative slope, and it should be going downhill. So again, I could do, now you can see here, I can't go down 3. I'm off the paper, but I can go up 3 and left 4. And that is the same line. I even have one there if I wanted it, if I needed it. And there's my line. Going clearly downhill. Okay. How about y equals -5/4 x plus 3. So again, my y-intercept is at 0, 3. So I go 1, 2, 3. It's on the y-axis, not the x-axis. And then I'm going to go -5/4 or 5/-4, which means down and right, or up and left. So down 5, 1, 2, 3, 4, 5, and right 4, 1, 2, 3, 4. Now I can go up 5, 1, 2, 3, 4, 5, and left 4, 1, 2, 3, 4. Connect my dots. It's clearly going downhill, which makes it negative, and that's a good thing. We have everything we need. Okay? Now, like I said, you can convert back and forth between the two if needed. Like, let's say this was 5y. Okay? In this case, we could not do the cover-up method because when we divide by 5, we'd have a nasty fraction, and that's hard to graph. We want nice intersections on the graph. So in this case, we need to solve for y, which means we need to move this over by subtraction. Now be careful here. This is not 4x. Okay? This is 5y equals, we always put the x first. Think about mx plus b. And then we divide everything by 5. Now this would still be kind of a nasty one because you'd end up with a y-intercept of 6/5, but we would never give you one like that. So let's make this 10 to make life easier. You might see one like this. Okay, so and 10/5 is 2. So this would be y equals -2/5 x plus 2. And that's very easily done with the slope-intercept form. But again, if you have it in standard form and both numbers are factors of c, there's no reason to spend your time doing this. This would only be if one of the numbers was not a factor, and it would lead to difficult graphing. Now let's take this one. Okay, very simple. All we want to do is have the x's and y's on the same side. So we would add 3x. And there we have its standard form. Okay, which you can tell this would not be a good one for standard form for the cover-up method because you'd have to divide -4 by 3 and get a fraction, so it wouldn't work. So this is best to leave in the form it's already in. That's pretty much it. There's your summary.